Hello. So today we're going to work out some reconstitution examples. And the first one I want to work out has this order of 500 milligrams IM every 6 hours for a patient with pneumonia. And then we have the supply of 1 gram, right? So this total amount inside here is 1 gram. And we're going to answer these questions below. So A says, how much diluent will you add? Well, we come over here and look that we notice this is an injection. So there's going to be some reconstitution involved, diluting, whatever it may. So that means we need to read these instructions. And I notice this first line here tells me 3.5 milliliters will be diluted. Awesome. So now B says, what is the resulting dosage supply? So again, we need to come back and keep reading some more information. And what you notice is the 250 milligrams per milliliter is my resulting supply. So 250 milligrams per milliliter. Now we want to solve for C. C says the resulting total volume. So that means we need to get the total volume that's in the vial, as well as the resulting supply. So we notice that the total volume is in 1 gram, it's in gram, and our resulting supply is in milligrams. And we know by now that there is one, for every 1 milligram, it's 1,000 milligrams. So 1 gram is equal to 1,000 milligrams. So if I just multiply this 1 gram by 1,000, I end up with 1,000 milligrams. So that would be my total volume in this container. And I'm going to divide it by my resulting supply and multiply by its volume. So the milligrams reduce. 250 goes into 1,000 4 times. It leaves me with 4 milliliters. Now, let's determine how many full doses are in this vial. So I know the vial has 1,000 milligrams because we already did that conversion. We know that we have an order of 500 milligrams. And for each 500 milligrams, that's just 1 dose, right? So the milligrams reduce, 500 goes into 1,002. So we have 2 full doses in this container. Okay, very good. So E says, how many milliliters will you give? So how many we're going to measure? So we're going to take our order, which is 500 milligrams. We're going to take our resulting supply and solve. Well, 250 goes into 500 2 times, and it leaves me with 2 milliliters. So very good, guys. So far, so good. Let's move on to our next example. Let's do a multiple strength solution. So a multiple strength solution tells me that I can have multiple dilutions going on, right? And I'm going to highlight this, hoping that you can read it better. So the label tells us that if you see here, it shows 20 milliliters. If it diluted, will yield 50,000 units per milliliter. So let's start with that. A asks us for, when you dilute 20 milliliters, what do we get? And we get 50,000 units per milliliter. Okay, so now we want to know the resulting total volume. Well, what is the total volume in this? Right here it says 1 million units. Very good. So I'm going to take the 1 million units, right? And we're going to divide that by our resulting supply. And then multiply it by the volume of it. And so 1 million divided by 50,000 is 20 milliliters. And I'm Make sure my notation's a little better. Our spacing is not as great. So it's 20 milliliters. And it kind of cut into the over here on D. So I'll do my best to scoot over. So on D, it says how many full doses are in the vial, right? So that means we got to take the total volume. And we're going to take our order. Well, what was our order? Our order is this 300,000 units per dose. And that's going to give me 3.3, and this 3 is repeating, but the decimal we don't need because we want a full dose, not a partial dose. So we're going to say it's 3 full dose in that vial. Now we want to know how many milliliters will you administer? So that means we got to take our order, right? Order was 300,000 units. And we're going to take our resulting supply. Make sure your comma looks like a comma. We get in a hurry sometimes and that doesn't look like it. So we got 300,000 divided by that 50,000. And it is a total of 6 milliliters. Okay, so that answered the question for 20 milliliters. What about the 10 milliliters right here? Well, we're going to dilute 10 milliliters and we will see that we have 100,000 units per milliliter. What is the resulting total volume? Well, we're going to take the 1 million units and divide that by 100,000 times 1 milliliter. And that should give us what, 10 milliliters? Yes, 10 milliliters it is. And now we're going to see how many full doses we get. Well, we're going to take that 1 million. Right, and then we're going to divide that by our order. It's per dose. And that gives me 3.3 repeating, so we're going to say 3 full doses. Kind of see the pattern here? Now I want to know how many milliliters we'll administer. So we're going to take the order. And we're going to take our supply. And we're going to administer 3 milliliters. Very good. So let's do 4 milliliters. So if we reconstitute 4 milliliters, according to this here, it says we get 250,000. So 250,000 units. Yeah, make sure that looks like a comma. Per milliliter. And then we want to know the results in total volume. So we know there's 1 million units. And we're going to divide this by the 250,000 units, multiply it by the 1 milliliter, and we get 4 milliliters. Okay, very good so far. Everything looks good. Kind of see the pattern. Look, A, okay, is the same as C. So if we do our math right, we're going to come out with what we diluted with to get, okay, so how many full doses are there? This should be the same as the other D's, as long as your math is correct. So what are we going to do? We're going to take our total volume and divide that by our order. And you notice we're still doing the same thing, right? So it's going to be the same answer. It's going to be 3 full doses. Because we didn't change the volume of the container we're working with. We didn't change that. We're still working with the same thing. So I'm going to say 3 full doses. How many milliliters will you administer? Well, the order was 300,000 units. We're going to divide that by 250,000 units times 1 milliliter. And then I'm going to double check my math. It's always good to double check your math. I know there'll be a point where you got these numbers, you can just spit them out left and right. 1.2 milliliters. So that leaves us with last one, 1.8, and it says that it's 500,000. So 500,000 units per milliliter. The resulting volume is the total volume divided by my resulting supply times the milliliters on the resulting supply, which gives me what, 2 milliliters? And then of course our 3 full doses. And then how many milliliters will you give? Well, we're going to take the 300,000 units from the order, and then our resulting supply, divide by it, times the volume of the resulting supply, and 0.6 milliliters is what you'll administer. So that was multiple dose. Let's do one more example, guys. So this next one says that we have this order, 400 milligrams IV every 12 hours. And we have this label that has a volume of 1 gram. And we notice over here, there's an insert that goes inside the package, inside the box, the container, because sometimes there's just not enough room on the label to put all the information you need. So the inserts are very important as well. Now, part A says, how much diluent will you need? Well, this container here is 1 gram. So I'm going to come over here to my chart, my insert, and look, it says the vial dosage size. We have a 1 gram, and that means the amount diluted to add is 9.6 milliliters. And make sure our decimals look like decimals. There we go. And now it says, okay, so what is the resulting supply dosage here? So let's go read our insert. Well, we see that it talks about concentration, and we keep reading, and then it says after reconstitution, we have 1 milliliter of solution that contains approximately 100 milligrams. We found it. It's going to be 100 milligrams per milliliter. Now, what is the resulting total volume? So again, we need to come back up here, right? Look at it. Well, that volume, the total volume in this container is 1 gram, and we're working with milligrams. So let's just go ahead and convert that 1 gram. We know for every 1 gram, it equals 1,000 milligrams, right? So 1,000 times 1 is just 1,000 milligrams. So I'm going to divide that by this here, my resulting, which is 100 milligrams, times that 1 milliliter of the resulting supply. And this gives me 10 milliliters. Now we want to know how many full doses is in this, this container, this vial. So what we need to do is take the total volume that's in the vial and divide it by the order, which is 400 milligrams per dose, right? And then when we do that, we get 2.5, but we're not going to say 2.5 because 0.5 is not a full dose. The actual full dose is 2 full doses. Do not round because 0.5 will not make a full dose. Now, how many milliliters will you administer? Well, we're going to take our order. We're going to take our resulting supply. And we come out with 4 milliliters is how much we will administer. And that is Reconstitution. Thank you, guys.